Welcome to the Chemistry, Biology and Math Revision Hub. Today we're doing the Pearson Edexcel International GCSE Chemistry Paper 2CR for January 2023. Let us begin with the first question. Question 1. In this question, the answer to each part is a number. Give the pH value of a neutral solution. A neutral solution is pH 7. In part B, give a pH value of a weakly acidic solution. I chose pH 5. But any value between pH 4 and 7 is acceptable. Then in part C, give the number of the group in the periodic table that contains the elements that do not readily react. This is going to be group 0, or you could say group 8. It's the same thing. Then part D, give the number of different elements present in glucose. We can see this is the formula of glucose. It contains carbon element, hydrogen element, and oxygen. So they are 3. So this brings us to the end of question 1. Let's continue to question 2. Question 2. The solubility of a solid depends on the solvent used. State one other factor that affects the solubility. Solubility is affected by temperature. The higher the temperature, the higher the solubility of a solid in a solvent. Then in part B, they say a student wants to find the solubility of a salt in water. The steps in the student's method are not in the correct order. So they've given us this specific order. Then down here they say, the flowchart shows the correct order of some of the steps. Complete the flowchart by putting the remaining steps in the correct order. So the first step is F. Put 50 centimeters cubed of water into a beaker. After putting the water in the beaker, since this is a solubility experiment, the next part should be putting the solid. So that's why I chose G. Add the salt to the water a little at a time and stir until no more dissolves. Then they've given us the next step is going to be B, which is filter to obtain 50 centimeters cubed of a saturated solution. And then D was record the mass of the empty evaporating basin. Then we have to pour the saturated solution into the evaporating basin. That's why I chose this, which is H. Pour 50 centimeters cubed of saturated solution into the evaporating basin. Then after that, we need to record the mass of the evaporating basin and the solution. That is why I chose C, record the mass of the evaporating basin and the salt solution. Then the next part is to heat, which is part A. Gently heat the evaporating basin and solution to remove all the water. And E is given, record the mass of the evaporating basin and the dry salt. So if you had written your answers in this order, then you get full marks. Moving on. Here they say these are the students' results. Mass of empty evaporating basin, which is that, and the mass of evaporating basin and dry salt, which is that. Then they say, calculate the solubility of the salt in grams per 100 grams of water. Here they've given us that 1 centimeter cubed of water has a mass of 1 gram, meaning the density is 1 gram per centimeter cubed. So here I began by finding the mass of the dry salt, which is going to be that minus that, giving us 17.6 grams. And then the volume of water given was 50 centimeters cubed, and since the density is 1 gram per centimeters cubed, the mass of water is going to be 50 grams. So solubility is going to be the mass of the dry salt divided by the mass of water times 100, giving us 35.2%. Here we multiply by 100 because it has to be per 100 grams. If this is in 50, it means twice of this is going to be in 100. That is why it's the same as multiplying by 2. If you cancel this one, that 2 is the same as multiplying by 2. So this brings us to the end of question 2. Let's continue to question 3. Question 3. When 10 kilograms of a solid fuel is burned, the heat energy produced is 3.28 times 10 power 5 kilojoules. They say calculate the heat energy in kilojoules per mole produced by the fuel. You should assume that the fuel is pure carbon and give your answer to 3 significant figures. Here they've given us the atomic mass of carbon, which is 12. So they've given us the mass of the solid fuel and they've given us the amount of heat that is generated. I'm going to find the number of moles of the fuel so that I divide this by the number of moles in order to get the heat energy in kilojoules per mole. So moles of the fuel are going to be mass divided by the atomic mass, but this mass is in kilograms, so I have to convert it to grams. That is why I multiplied by 1,000 to convert the 10 kilograms into 10,000 grams. So the 10,000 grams, which is the mass, divided by the atomic mass, which is 12, gave me this as the number of moles. The energy is going to be the heat generated here divided by the number of moles, giving me that. But they said the answer has to be in 3 significant figures. So rounding this off to three significant figures, I got 394 kilojoules per mole, and that is my answer here. And down here they say, in part B, the fuel actually contains some impurities, including sulfur. They say there is 600 grams of sulfur in 20 kilograms of the fuel. Calculate the percentage of sulfur in the fuel. So here I have to operate in the same units if I want to find the percentage. Since this is in grams, I can also convert this to grams so that the percentage of sulfur becomes the mass of sulfur divided by the mass of the fuel in grams times 100. And you can see here I converted it to grams by multiplying by 1,000. 10 power 3 is 1,000. So 600 divided by 20,000 times 100 gave me 3%. So the percentage of sulfur in the fuel is 3%. Moving on. Here they say, when the fuel burns, the 600 grams of sulfur produces sulfur dioxide gas. We can see this is the equation. They say calculate the volume in centimeters cubed of sulfur dioxide gas that will be produced at room temperature and pressure when the fuel burns. They say for a gas, molar volume is 24 decimeters cubed at room temperature and pressure. I'm going to use the mass of sulfur and the atomic mass of sulfur to find the number of moles of sulfur, and then I'll use the mole ratio in order to get the volume of gas that is produced. So here, moles are going to be mass divided by the atomic mass, giving us that in mole. And then the moles of sulfur dioxide are going to be similar to that because the ratio is 1 to 1. So they have the same moles. So volume of sulfur dioxide is equal to the number of moles, which are these, times the molar gas volume. However, here they say they want the answer in centimeters cubed. So I converted the molar gas volume from decimeters cubed to centimeters cubed, and it's going to be 24000. So multiplying these two, I get that. So my answer is 450,000 centimeters cubed. And lastly, they say, state the name of the environmental problem caused by sulfur dioxide in the atmosphere. Sulfur dioxide causes acid rain, so that should be your answer here. So this brings us to the end of question 3. Let's continue to question 4. Question 4, hand sanitizer liquids are used regularly to reduce the spread of infections. 3 compounds P, Q, and R are often present in these liquids. So we have P, which is ethanol, we have Q, which is propan-1O, and we have R, which is propan-2O. So here they say what type of formula is shown for P. This is a structure formula, so this was my answer. And down here they say, compounds P, Q, and R are members of the same homologous series. Give 2 properties of a homologous series. Members of the same homologous series have the same general formula. For example, for alkanes, it's going to be CN, H2N plus 2. Also, members of the same homologous series have similar chemical properties, meaning they react the same way. Members of the same homologous series have the same functional group, and they have a trend in physical properties. Also, each member differs from the next by a CH2. And next they say, name the homologous series that contains compound P, Q, and R. If I go back up here, we can see all of them have OH, and that means they are alcohols. So the homologous series is going to be alcohols. And then they say give the name of compound Q. Compound Q, which is that, is going to be propan-1O. It is because the functional group is attached to this carbon, so this is going to be carbon 1. So we say propan-1O, and that is why this is propan-2O, because the functional group is on carbon 2. So my answer here was propan-1O. Here they say diols and dicarboxylic acids react together in polymerization reactions to form polyesters. Explain the name given to the type of polymerization that occurs in these reactions. Reactions where diols and dicarboxylic acids react produce polyesters, and these are through condensation reactions, and that is because there is loss of a water molecule. In this case, I said water because it's diols and dicarboxylic acids, but I put PS here. There is another type of condensation reactions where HCl is lost, and those include when you have a diacyl chloride and a diol. So down here they say complete the equation for the polymerization reaction by giving the displayed formula of the repeat unit of the polymer. So these are the compounds that are going to be used to make the polymer. They're combining that and that. And since this is a dicarboxylic acid and that is a diol, an alcohol always loses a hydrogen while a carboxylic acid loses OH. So in my answer, this oxygen is that oxygen. Then we bring this group here which is that. Then after losing this hydrogen, that oxygen is going to be connected to this carbon. And then on the other side, that is going to go away, which would be the connection here. So this is going to be my repeat unit. And then water molecules are going to be produced as the byproducts. So this brings us to the end of question 4. Let's continue to question 5. Question 5. This question is about the element phosphorus and some of its compounds. The atomic number of phosphorus is 15. Give the electronic configuration of an atom of phosphorus. If its atomic number is 15, then the electronic configuration is going to be 2, 8, 5, because these are 10 electrons plus 5, creating 15. And in part B, calcium phosphide is an ionic compound used in pest control. The formula of a calcium ion is Ca2+. Explain why the formula of calcium phosphide is that. Because calcium is 2+, phosphide is going to be P3-, like I said here. So to create a neutral compound, it means 3 calcium ions have to combine with 2 phosphide ions so that this compound, which is neutral, is created. So that was my answer here. And in part C, calcium phosphide can be produced by heating calcium phosphate with carbon. Complete the equation for the reaction. So this is what we're given, and we're given that. So we have to balance this equation. I began by looking at the numbers of oxygens. We can see there are 4 here, but times 2, which is 8. Since oxygen ends up in one product, it means this is going to be 8 because at the product side, this is the only compound with oxygen. But when we make this 8, carbon also becomes 8, and that means this is going to be 8 as well. So next they say, explain the role of carbon in the reaction. Here, carbon is acting as a reducing agent because you can see it takes away oxygen from this compound here. So I said carbon is a reducing agent because it causes calcium phosphate to lose its oxygen. Moving on. In part D, calcium phosphide reacts with water to form calcium hydroxide and phosphine, which is that. They say give a chemical equation for this reaction. We were already given calcium phosphide. Also, we know the formula of water. And we know calcium hydroxide is going to be like that. We also have phosphine. So it was about balancing the equation. Since we have 3 calciums on the reactant side, I put here 3. And we have 2 phosphorus atoms on the reactant side, so I put a 2 here. But after doing that, the hydrogens became 6 here and 6 here, making it 12 in total. So I had to put a 6 here to make 12 hydrogens. Also, to balance the oxygens, we can see they only ended up here, which is a 2 times 3 creating a 6, so everything is balanced. In part E, explain why calcium phosphide has a high melting point. You should refer to the structure and bonding in your answer. We know calcium phosphide is going to be an ionic compound, and all ionic compounds have giant ionic structures, which have multiple oppositely charged ions. These ions have stronger forces of attraction between them. So to separate them, a lot of energy is required in order for those forces to be overcome. So this brings us to the end of question 5. Let's continue to question 6. Question 6. Iron metal was discovered several thousand years ago and is produced industrially from iron 3 oxide by extraction using carbon. Sodium is a metal in group 1 of the periodic table. Sodium was discovered by Sir Humphrey Davy in 1807. It was produced industrially by the electrolysis of sodium chloride. In part A, they say, explain using the reactivity series why carbon can be used to extract iron from iron 3 oxide. Now, in the reactivity series, carbon is above iron. That means carbon can remove oxygen from iron 3 oxide in order for iron 3 oxide to be converted into iron. And down here they say, suggest why sodium was not discovered until 1807. This is because electrolysis was not discovered before 1807, so sodium could not be extracted out of its ores. And in part B, the diagram shows a simplified version of the Dawn cell, which can be used to produce sodium industrially. The electrolyte is molten sodium chloride. So we can see the sodium chloride is added here. Chlorine gas comes out from there. This is the electrolyte. We see the steel cathode. There is a carbon anode. Then the molten sodium leaves here. Then they ask, explain why the molten electrolyte conducts electricity. The molten electrolyte can conduct electricity because it contains free ions, and these free ions can move in order to conduct electricity. The next they say, what is the formula of the cation in the electrolyte? Since the electrolyte is sodium chloride, the cation is going to be sodium cation, which is sodium plus. And then they say, during the production of sodium, small explosions can be heard. Explain why using sodium chloride that is not completely dry could cause these small explosions. Here, because sodium is going to be a product, it means the produced sodium in the presence of those damp or wet conditions is going to react with the water, and then that is going to produce hydrogen, and hydrogen is going to interact with oxygen in order to produce those explosions because hydrogen is an explosive gas. So I said, because the water present reacts with sodium, this produces hydrogen gas. The hydrogen reacts with oxygen in the air to form the small explosions. And then they say, give ionic half equations for the reactions at the anode and cathode. The anode is the positive electrode, so the negative ions are going to be attracted there, and these are the chloride ions. Each of the chloride ion is going to lose an electron, so since we have two ions, they're going to lose 2 electrons in order to produce 2 chlorine atoms that are going to bond with each other to produce chlorine gas. And then at the cathode, which is the negative electrode, the cation, which is sodium, is going to be attracted there. And then this is going to gain the electron to produce sodium. However, because 2 electrons were lost there, I used 2 electrons here to be gained in order to produce 2 sodiums in the end. Moving on. In part C, explain why the reactivity of metals in group 1 increases from lithium to potassium. As you move down the group, there are more shells that are added, and that means the outer electrons, those electrons that are going to participate in the reaction, are going to be farther away from the nucleus, and they're going to be easily lost because the attraction towards them from the nucleus is going to be decreased. So I said, moving from lithium to potassium, due to increase in the number of shells, the outer electrons are farther from the nucleus. So electrons in potassium are less attracted by the nucleus compared to those in lithium. So outer electrons in potassium are easily lost, meaning in reactions. So this brings us to the end of question 6. Let's continue to question 7. Question 7. A student is asked to find the concentration of a solution of nitric acid by doing a titration. The student is provided with sodium hydroxide solution with a concentration of 0.350 mol per decimeter cubed. These are the first 4 steps in the student's method. Use a pipette to add exactly 25 centimeters cubed of the nitric acid solution to a conical flask placed on white tile, and then add a few drops of the indicator to the flask. And then use a burette to add sodium hydroxide solution to the flask until the indicator has changed color. Then record the volume needed for the indicator to change color. So the first question says, give the reason for using the white tile. The white tile is used in order to see the color change at the endpoint more clearly. And then next they say, universal indicator is not a suitable indicator to use in a titration. Complete the table to show the name of a suitable indicator and its final color in this titration. Now, because the conical flask is going to contain nitric acid and the burette contains sodium hydroxide, it means the color change at the end is going to be the color we would see in sodium hydroxide. So phenolphthalein is going to be pink in the end, and then methyl orange is going to be yellow, but orange is acceptable as well. In part C, the student wants to obtain an accurate value for the volume of sodium hydroxide solution needed to neutralize the 25 centimeters cubed of nitric acid. Describe all the further steps the student should take. In order to get accurate results, they need to rinse the flask with the ionized water, and then they have to record the initial and the final burette reading. During the titration, they should add while swirling the conical flask. Also, they need to add sodium hydroxide from the burette dropwise when they are approaching the endpoint. They need to repeat the experiment until concordant titer values are obtained, and then they need to use those concordant results in order to calculate the mean titer. Moving on. In part D, this is the summary of the student's results. So we have the volume of nitric acid, which is that, the concentration of sodium hydroxide, which is that, and the volume of sodium hydroxide solution needed to neutralize, which is that. So they gave us the equation. I wrote the information from the summary around the components, like this is for nitric acid, and these two are for sodium hydroxide. So the first question says, calculate the amount in mole of sodium hydroxide that reacts. I'm going to use this information, which is that concentration and that volume. So number of moles is going to be concentration times volume, which is equal to this concentration times the volume. But I divided it by 1000 in order to convert it to decimeters cubed. And my answer was that in mole. Determine the amount of moles of nitric acid that react. So when you look at the reaction equation, the mole ratio is 1:1, meaning the moles of sodium hydroxide are equal to the moles of nitric acid, and therefore this is the same answer. And lastly, they say calculate the concentration in mole per decimeter cubed of nitric acid. Concentration is going to be number of moles over volume, which is that, divided by the 25 centimeters cubed. However, I divided that by 1000 in order to convert this volume to decimeters cubed. And my final answer was that, which is that to 3 significant figures in mole per decimeter cubed. So this brings us to the end of question 7. Let's continue to question 8. Question 8. This question is about reactions involving nitrogen. In our car engine, nitrogen reacts with oxygen to form nitrogen monoxide. The equation for the reaction is as we can see here. So the first question says, draw a labeled reaction profile diagram showing delta H and the activation energy for the reaction. On the vertical axis, we have the energy, and on the horizontal axis, we have progress of the reaction. This is if you're talking about a reaction profile diagram. We have to put 2 energy levels, one for the reactants, which are these 2, and the other for the products, which are those. And then we need to put an activation energy hump connecting to the product side. Because this is an endothermic reaction, the products are higher in energy than the reactants, so we see delta H is positioned as positive 181 kilojoules per mole. And then this is going to be the activation energy. In part B, in the Haber process, nitrogen reacts with hydrogen to form ammonia. This equation represents the reaction. So nitrogen plus hydrogen giving us ammonia. And they say the table gives the values of some bond energies. So these are the bond energies in the table. They say calculate the total amount of energy in kilojoules needed to break the bonds in the reactants. From the reactant side, we have 1 nitrogen-nitrogen triple bond corresponding to that, and 3 hydrogen-hydrogen bonds corresponding to that same 3, which is what I put here, and adding it up, I got 2252 kilojoules, which is going to be my answer here. And next I said, calculate the total amount of energy in kilojoules released in forming the bonds in the product. So the product side has, we can see 1, 2, 3 times 2. Those are going to be 6 nitrogen-hydrogen bonds. So it's going to be 6 times that. And my answer is 2346 kilojoules, as we can see here. And lastly, they said, calculate the enthalpy change, delta H, for the reaction. You should include a sign in your answer. So delta H is going to be summation of bonds broken minus the sum of the bonds formed, which is going to be that minus that, giving us negative 94 kilojoules as my answer here. So this brings us to the end of question 8, as well as to the end of this paper. Thank you for being with us. Do not forget to subscribe. See you in the next video. Bye-bye.